An empty bucket has a mass of 1.2 kilograms and an internal volume of 0.015 meters cubed. The bucket is used to lift water from a well. The bucket is attached to a light inextensible rope which winds onto a rotating cylinder of radius 0.2 meters when a handle is turned. To lift a bucket completely full of water at constant speed, it is necessary to apply a force of 250 newtons to the handle that acts along the tangent to the circle of radius 0.6, in which the handle moves. So a lot of words so far. Let's see what this means. The energy required to lift the bucket is wasted energy. What's the efficiency of the system in lifting water from the well? Well, we're having to apply a force of 250 newtons here to lift this bucket of water. So every time we crank this handle, we're having to complete one full rotation of the cylinder in order to lift this bucket of water. So some people might think to use moments here, but it actually makes more sense to use energy because, again, we're talking about efficiency of the system. So how much energy we're putting in, how much energy we're getting out that's useful. So we have a bucket of water, which is 1,000 for its density times the volume. 1,000 times 0.015 gives mass of water. It's 15 kilograms. We're lifting this up using a force of 250 newtons. So that means 15 times 10 for G times the height would go, let's say one complete rotation. So that would be 2 pi times 0.2. That's the useful energy. If we divide this by how much energy we're actually having to put in, this is 250 times 2 pi times 0.6. Again, 2 pi r is a perimeter, so if we complete one full cycle, 2 pi r, then that's the distance that we go through in moving this handle, and then the actual distance the water or the bucket would lift up would be that 2 pi by 0.2 as the rope winds on to the cylinder. We can cancel out some things here, so 2 pi can cancel out a 10. We get a 15 over 25, which is 3/5. But then we also get 0.2 over 0.6, which is 1/3. Cancel out the 3, we get 1/5, which, as you can see, is 20%. So the answer is C. We just use the energy put in cranking that handle, and the energy, the useful energy that we got out, which is that GPE increase. So hopefully that makes sense. But if you have any questions, let me know in the comments.